Okay, so I did not mention this in the morning. So in this class, I'm going to write a lot of things on the whiteboard. The reason is this book is already has roughly 300 pages, and I do not want to increase the size of this book anymore because it's going to cost you more. And therefore, I'm going to write a lot of examples on this board, and you have to take those examples. So some of those test questions come from the example that I'm going to write on the page. Because of that, you might need to keep a good notebook with it because you may not have enough space to write everything on these slides. Already there are some contents in these slides. So it is a good practice to keep a separate notebook, and you can track your notes by the chapter and lecture slide number. Okay, so I'm pretty much sure everyone learned what I'm going to talk about in this short lecture, but this is kind of a refresh for you. Okay. So first we are going to start from the place value. Okay, so there will be 3 questions in the exam based on the place value. Because in chemistry, we are going to record our values as numbers. So when we write a number, you need to understand the place value of these digits. So when it comes to these numbers, or when we write a number, every number has 2 different values. So as an example, when we write 5, 5 is the face value of its digit. But if this 5 is in a number like 257.19, there's another value for this 5, and it is the place value of this 5. So depending on the place of this digit in the number, there's a place value. So we're going to talk about those place values. So we have 10 digits from 0 to 9, and that's why our number system is called decimal. There are 10 symbols. So 10 is called decimal. Okay, so in order to identify the place value of a digit in a number, you're going to locate the decimal symbol, and the first digit before the decimal is called, what is the place value? Anyone? Ones. Ones, picture. Okay. So it's ones. So 5 is in the tens. This is in the hundreds. Those place values ends by S. So this is the decimal side of the digits, and this place value is called tens. This is called hundreds. Each of these places has its own mathematical value. So one's place means any number in this place multiplied by its place value. So this 7 has its place value as 1. So total value comes from this digit is 7 times 1, which is 7. So 5 is in the tens place. So 5 place value is 10. 5 times 10 is 50. So 2 is in the hundreds place. So it's multiplied by 100. 2 times 100 is 2. Okay, so you can see these are multiples of tens. So 1, 10, 100. So for this side, it's going to divide by 10. So tens is the first decimal digit, and tens means it's 1 over 10. 1 divided by 10. So 1 divided by 10 is 0.1. So which means this 1 multiplied by 0.1. Okay, so it's 0.1. So 9, it's going to be 1 divided by 100. So 1 divided by 100 is 0.01. So anything in this place multiplied by 0.01, so it's going to be 0.09. Then we can add these digits. This adds up to 257.19. Okay. In the exam, definitely there will be one question to identify the place value of a digit in an answer. So it's a simple question, don't miss it. Any question? Okay, so I have a slide related to this, two examples, the one without decimal places. The two is in the thousands place. So this is one, tens, hundreds, and thousands. So 6.407, 6 is in the ones place, 4 is in the tens place, 0 is in the hundreds place, and 7 is in the thousands place. So if you have this proof, you can fill this. So you can use the place value by standard form, like this is 1, 10, 100, 1000. So this side it's going to be 0.1, 0.01, 0.001. And also we can write these numbers in scientific notation. So how many of you have learned scientific notation from another class? Okay, so some of you have learned scientific notation. So scientific notation is a way to express these standard numbers with an exponent. So in our number system, our base is always 10 because these are multiples of 10. And let me explain the place value of each of these. So the first place value is 1. We can write 1 as 10 to the power 0. 0th power on any number is equal to 1. So first place value, 1's place value is equal to 10 to the power 0. If the place value is 10, 10, 10 to the power 1. So this is equal to 10 times 1. If the place value is hundreds, this is equal to 10 times 10. So we have 2 tens, that is the power 2. Place value is 1000. 10 times 10 times 10. So I'll go over this again later in this chapter when we talk about scientific notation. So that's the positive side or multiplication of tens. So when it comes to the decimal side of a digit, tens place is 0.1. This is equal to 1 divided by 10. So we can write 1 divided by 10 as 10 to the power 1 because 10 is equal to 10 to the power 1, but it's in the denominator. So we can switch the numerator and denominator and write it as 10 to the power -1. So decimal place value is going to get negative exponents. So 10th place is going to be 10 to the power -1. Next one is 0.01, which is equal to 1 over 100. So 1 over 100 is equal to 10 to the power 2. So this is 10 to the power -2, like that. Next one is 0.1, is 1 over 1000. It's equal to 1 over 10 to the power 3. It's equal to 10 to the power -3. So that's the scientific notation of these place values. And we are going to talk about scientific notation again later in this chapter. Okay. Any question? So if you need more time to note down these things, just let me know. And also, if you have any question, please feel free to stop me and ask questions. Quick practice problem. So you have two numbers, 15.24 and 731.965. So identify the place value of each digit in these numbers. If you don't have this lecture notebooks, simply you can write the two numbers and write place values. So you don't need to create those fancy tables. Okay, so what is the place value of 2 in this digit, in this number? What is the place value? 10. Okay, so what is the place value of 1? 10. Just yes. So 5 is in the ones place and 4 is in the hundreds place. Okay, so what is the place value of 3 in this digit? What is the place value of 5? And 6 is in the hundreds. 9 is in the tens place. 1 is in the ones place. 7 is in the hundreds place. Okay, so next one is positive and negative numbers. So normally when the number is a positive number, we don't write the symbol, but if the number is a negative number, we place the negative symbols in front of the number. That's how we recognize the positive and negative numbers. Okay, my question is 2.5 times 10 to the power negative 3. Is this a positive number or negative number? Is it a positive number or negative? Positive. Good job. Okay. Because there's one negative sign at the beginning of the number. So this is a positive number and it's written in scientific notation. So we are going to talk about that today. So this number in the standard form is going to be 0 to 5. Okay, so that's the number in the standard form. Both are equal. Okay, so multiplication and division. I'm sure all of you know the rule. I just want to highlight it because we are going to multiply different types of numbers. Keep this in mind because sometimes when you miss a sign on your calculator, you might end up with the wrong answer. So if you know the rule, you can apply your rule and check the answer. So when you multiply two numbers with the same sign, positive, positive, or negative, negative, answer is always positive. And it is true for multiplication and division. When you multiply or divide two numbers with the opposite sign, answer is always negative. Okay, so you have examples. Two positive numbers, answer is positive. Two negative numbers, answer is positive. Division is also same. So when you multiply two numbers with the opposite sign, answer is always negative. Or when you multiply two numbers with the opposite, divide two numbers with the opposite sign, answer is always negative. Okay, so there's a mistake on this slide, so I don't know how I'm going to fix that. Addition and subtraction. When you add two numbers with the same sign, forget about the sign of the two digits, simply add the absolute value of those two digits. So positive numbers and negative values, absolute value is always positive. So forget about the sign of the two digits. So 4 and 3, those are absolute values. So 4 plus 3 is 7. And then use the sign of the two digits. Both are positive, answer is positive. At the absolute value, 4 and 3, 7. Both are negative, so answer is negative. And when you add two numbers with the opposite sign, consider the absolute values and find the difference. So next example is 12 and 7. Absolute values are 12 and 7. So difference is large one minus the small one. So 12 minus 7 is 5. And then go with the sign of the large absolute value. So large absolute value is 12, positive, answer is positive. So 14 and 8, difference is 6. Large absolute value is negative, so answer is negative. That's the rule. When you subtract two numbers, we do not have a separate rule for subtraction. So we convert subtraction into addition by doing a small modification. So we keep the first number, keep. You change the sign. Negative into positive, and then change the sign of the second number. Example, subtraction of positive 16 and 9. So we keep the sign of the same digit, so we keep it. Change the sign of the negative into positive, and this is positive 9, so we change the sign of the second number, so it's negative. So now this is a addition of two numbers with the opposite side, so we apply addition to it. So opposite side, consider the difference, 16 and 9, 7. And sign of the large absolute value is positive, and this is positive. Okay, so you can use the calculator always in my class, but sometimes if you know these rules, and if you have different sign with your numbers, you can apply these rules to verify your answer. Because if you miss one sign on your calculator, you might end up with the wrong answer. And that's why it is very important to practice your calculator skills. And I recommend you to keep your calculator always with you, because when I'm doing a calculation on this screen, you can practice it with your calculator and you can improve your calculator skills. Especially in second exam, most students miss their correct answer based on the calculator skills. So you might do all the work, but you might not do it correctly on your calculator. That's kind of a bad thing, so practice your calculator skills. And I may have few extra calculators on front table, so I will bring those to the next class. So you're free to use those. And if you have your own calculator, try to work on these questions and practice your calculator skills. And especially when you type scientific numbers like this, 2.5 10 to the power 53 divided by something like 102 times 10 to the power negative positive 3. So this is an example that you might do in the third chapter. So you may need to practice your calculator skills with scientific numbers, because you can't type this number in the standard form, a large number. Okay, I will explain this again when it comes to chapter 3, but practice it. Okay. So next topic that I'm going to cover is another important topic that we are going to use in different places, calculating a percentage. Okay. So there are a few places that you are going to report your answer as a percentage. So when you calculate the percentage, you need to identify two numbers. So when you calculate a percentage, you need two numbers. Those two numbers are specified and total. So this is how we are going to calculate any percentage value. So specified item will be in the question. So like in this question, an aspirin tablet contains 325 milligrams of aspirin, active ingredient, and the tablet has a mass of 545, because when we take a tablet, the 100% of the tablet is not the active ingredient, because it has a bind and some other stuff. So in this question, we are going to calculate the percentage of aspirin in the tablet. So it's specified is aspirin, and it says amount of aspirin is 325. It goes to top. And total mass of the tablet is 545 milligrams. So that's the total mass. It goes to the denominator. Now, we're going to divide the specified by total times 100. Don't forget this. So if we did not multiply it by 100, the answer is going to be less than 1 most of the time. Okay. So make sure to multiply it by 100 and answer is 59.6. So that's the percentage of aspirin in 100. So the advantage of this percentage is we can think about out of 100. So if we take 100 milligrams of that tablet, 100 milligrams of tablet, it contains 59.6 grams of aspirin. That's the meaning of that percentage. So we can take it out of 100. So like this example, the percentage represents the number of parts of an item in 100 of those items. So if there's a bag with 100 balls, and if the percentage of red balls is 5%, 5 of those are going to be red, and third is 100. And remaining 95 is going to be different colors. So 50 green balls means 50 greens out of 100 balls. Okay, why this is neat? So first place that you're going to do a calculation of percentages is lab 3. So lab 3 has a pre-lab, and there's a question. In that question is question number 3. And it has 5 parts. So first 4 parts is exactly similar to this question. Okay. So fifth one, there's an equation in the background information, so you can answer fifth part based on that equation. This is the help for first 4 questions. It's a simple calculation, and you might see different numbers and different other explanations, but your work is going to be same. So I'll give you a minute to work on this question based on what we learned. So you're going to calculate the percent of salt in the original mixture, percent of sand, and percent of recovered, mass of recovered, and percent of recovered. I'll give you a couple of minutes to find this answer. If you don't have a calculator, use your phone. Did anyone calculate the percent of salt? What is the answer? Yes, 19.75. So now we can see the specified item is salt. So read the question and identify the amount of salt recovered. So it says 0.32 grams of dry salt recovered. The specified is 1,000. And total sample mass is 1.62 times 100. Percentage values doesn't have any unit because it's going to cancel out. And you get a percentage difficult for the final answer. So when you divide 0.32 by 1.62 and times 100, it's 19.75. Is it? Okay, so calculate the percent of sand in the original mixture. The amount of sand recovered is 1.17. Total sample mass is 1.62 grams times 100. And this is equal to 70. So 2.22 or 28. What is the decimal? So next one is calculate the total mass of the sand and salt recovered. What is the answer? Total sand and salt recovered. 31. So that's it percentage. So that's why I put this question. So this is a mass, total mass. So you're going to add the two masses, 0.32 and 1.17. So 0.32 grams plus 1.17 grams. So this adds up to 94149 grams. So it's a mass, so unit is grams. And last one is the answer. The answer is for the last one. So that's the percent of recovery. So percent of recovery is going to be amount of recovered, that's the specified item. The amount of recovered divided by total sample mass, and it's going to be 92%. So at this point, you don't need to worry about the number of decimal places that you need in the answer, and we will talk about that in chapter 1. Okay. So how many decimal places we need in final answer? It will be in chapter 2. Okay, so we did not work on that question. You may record these answers. Is everyone good? Are we good to move on to the next one? Okay, let me give you a quick problem out of percentage. Okay. So normally I may have like 1 or 2 questions that you may need frequently like this. Okay, so this is my question. Okay, the shop sold 8 white shirts, 5 red shirts, and 7 green shirts on a day. What is the percent of white shirts sold on that day? What is the answer? Good. So in this question, I did not give you the total. Okay, but it's always specified over total. Specified is white shirts, 8, and total is not explicitly mentioned in the question, but it's 8 plus 5, 13, 13 plus 7 is 20. It's shop sold 20 shirts. That's 100. Question. Next slide. Linear equation. So I'm sure you have learned this in another class, but I will show you all the basic steps to solve a linear equation because you're going to solve a lot of linear equations in my class. Okay, so linear equations are the equations with one unknown variable. So we use English letters like X, Y, Z to represent these unknown variables. So as an example, 2x plus 7 equal to 13. So this is an equation, and this equation, sometimes we may have one solution, only one answer, and sometimes we can have infinite number of answers or no answers. There are 3 different types of linear equations, so that's from your math class. But in my class, you are going to get only equations with one solution. So this equation has one solution, and we are going to find that solution. So when we find a solution for a linear equation, our object is to isolate the unknown variable on one side of the equation and get an equation like x equal to a number and a number equal to x, like this, one of the 2 forms. So in order to simplify this given equation into one of these simplified forms, we always do the opposite of the term that we need to remove from the side. So as an example, so in order to isolate x on left side of the equation, we need to get rid of plus 7. So opposite of plus is subtraction or negative. So we subtract -7, and you have to do it for both sides of the equation. So equations are like balances. You can't add or subtract from one side, so you have to add or subtract the same thing to both sides to keep it valid. Okay, so that's why we subtract it from both sides. Okay, so let me rewrite this. So this is what we have now. So we have 2x plus 7, and we added -7, and the other side is going to be 13 subtract 7. So this is same and opposite, so it cancels out because it's 0. Plus 7 minus 7 is 0. Now we have 2x equal to 13 minus 7 is 6. So now you can see there's a coefficient in front of the variable. So 2x means it's 2 times x. So this is the multiplication. Okay. So opposite of multiplication is going to be the division. So we divide both sides by. So 6 divided by 2 is equal to. So we can substitute 3 into this equation, and we end up with the same answer on both sides. So it's 2 times 3 plus 7. So 2 times 3 is 6. 6 plus 7 is 13. So 13 is equal to 13. So it's a true statement. That's how you verify the answer. Okay, so that covers all the basic steps to simplify a linear equation and find a solution. Now let me give you a practice problem. Okay, so there are two practice problems, and I'll explain those two. Did anyone finish both questions? At least first one. Are those correct? Okay, so let me quickly go over these two. Right, so there's relation. That's fine. The first term that we need to get rid of is -6. We are going to add +6 for both sides. cancels out like this. Now we have 2/3 of y equal to 12 plus 6, which is 18. So now this is our coefficient for y. So this tells us it's going to multiply y by 2 and divide by 3. So we do the opposite. So we are going to multiply this by 3 and divide by 2. And then we have 2 over third y 18. We need this on both sides. We are going to multiply it by 3 and divide by 2. Like that. So this is called the reciprocal of this fraction. So 3 times 1 cancels out, 2 times cancels out. So everything is going to be 1. So 1 times y is 5 equal to 18 times divided by 2 is 9, 9 times 3 is 22. That is going to be the answer. Then not down this. No. So if I'm fast, just let me know. So I'll slow down. So next question is 4 over 5 x plus 12 equal to -20. Negative 4 over 5 x 12 equal to -20. We're going to do the same thing. So this is plus 12, opposite is -12. Okay. Cancels out. Now it's going to be negative 4 over 5x equal to -20, -12. Same sign, add the two numbers. 32, sign of the numbers, negative. So it's -32. So now our coefficient has a negative symbol. So to make it positive, we are going to multiply it by the same negative number. So negative times negative makes it positive. So we can multiply both sides of this equation by -5 over 4. Negative times negative, answer is positive. So 5 and 5 cancels out, 4 and 4 cancels out. So it's going to be x. The other side is going to be negative times negative, answer is positive. So 32 times 5 is going to be 160. 160 divided by 4. 40. Any question? There are a couple of ways that you can solve these equations. So this is a one way. So there are other ways that you can do. Okay, so if you don't have any questions, let's go to the next topic. So next topic is the scientific notation, and this is one of the important part of this basic math skills. Okay. So when we write a number in scientific notation, we have to have 3 components in that scientific notation. So those 3 components are coefficient, base, and power of 10. So this is the power of 10. So we have to have all 3 to write a number in scientific notation. Okay. So let me explain how do we convert a standard number into scientific notation. So I'm going to start from a simple number, like 395. So this is the standard way to write a number in the decimal system. So if you want to convert this into the scientific notation, first we are going to locate the decimal point. So this doesn't have any decimal point, so it should be after 5. So normally we don't place the decimal symbol like that, but it's after 5. So once we find the location of decimal point, we are going to move this number, decimal point, until we change this number into this range. So this is the required range for the coefficient. So our coefficient must be greater than or equal to 1. Less than 10. Okay, so if we go for this direction, we have to add more zeros. So it's going to increase like 3,950. So that's not the direction we need to go to lower this number into that range. So therefore, we need to move this decimal place toward the left side like this. So now that number is going to be 39.5. Okay, so we are going for the right direction. Okay, one more times. So that number is going to reduce into 3.95. Okay, so now you can see this number is in the range of 1 to 10. So it should be greater than or equal to 1 and less than 10. That's our coefficient, which is the first part of the scientific notation. Okay, so second component is the base. And our number system is in decimal form, so it's going to be 10 always. So base is always 10. And then we need a exponent, and exponent magnitude of the exponent is going to be the number of times that you shifted the decimal place. So from here to here, we shifted our decimal place 2 times. The magnitude of the coefficient is 2, and next one is the sign. So sign is positive if the given number greater than 10. Okay. So exponent is positive the given number greater than 10. Okay, so normally we don't write positive 2 like this by default without the sign, it's positive. Okay. So this power or exponent can be positive or negative depending on the number. So 395 is greater than 10, so this is positive. So meaning of 10 to the power 2 is 10 times 10 is 100. So if you are going from the scientific notation back to standard form, we are going to expand this base and exponent and convert into the standard form. 3.95 10 to the power 2 is 100. 3.95 times 100 is 395. That's how we go from scientific notation back to standard form. So you need to practice both of these. Okay, so the other method is we can consider the directional of the shift. So if you are going to shift the decimal point toward the left to get the scientific notation, then sign is positive. So to remove positive scientific, a positive exponent from scientific number, you're going to shift it for the other direction, like when it is 3.95 times 10 to the power 2. To remove this, you're going for the opposite direction. To get positive exponent, it goes to left. To remove it, it goes to right. We can practice the method that is easy for you. So I have explained 2 methods. The next one is a number less than 1, like 0.000691. Okay, this is a decimal number less than 1. So we are going to convert this into the scientific notation. So if we're going to shift the decimal place to the left side, it's going to add more zeros, so it's going to go further away from range. So that direction doesn't work for us. So we're going to shift it toward right side like this. 1, 2, 3, 4 times. So once we shifted the decimal point 4 times toward the right side, our number is going to increase up to 6.1 times 10 to the power number of times 4. Okay, so now the sign must be negative because we shifted it toward the right side. So if the direction of shift is right, sign is negative. That's one way to remember that. If not, if the given number less than 1 function of exponent negative. So most of the time, some students, not all, so some students might end up with the wrong sign. So please keep this in mind. So you should be able to understand the sign of the exponent, whether it's positive or negative. Okay, so let's try few examples. Do you want me to explain more questions? Is everyone ready to do some your own? Okay. Question. Is the scientist station. If the number given in scientific notation, convert that into standard form. If it is in the standard form, convert that into scientific notation and ask 5 questions. And last one, written in standard form, so convert it to scientific notation. Okay, so what is the scientific notation of the first number? Anyone, what is the answer? 3.9254 times 10 to the power positive 3. Yes, good job. Okay, so next one.
0.6 times 10 to the negative 3.
Good job. Okay. The next one is given in the scientific notation. So what is the standard form of that number?
1,970.
Yes, it is. So 1977. So this is positive 3. To get positive 3, we need to shift toward the left side. So to remove positive 3, we're going for the opposite side. So it's going to increase the number. So it's going to end up with a larger number than 10. So next one is negative. So you should end up with a number less than 1. So what is the number?
Oh, wait, 0.
Okay, 6. Okay, so how many of you have answered the last one? What is the answer? Did anyone answer last question?
I guess. Would
Yeah.
it be 4.63 times 10 to the power of 0?
Yes, it is. So 4.63 times 10 to the power 0th power on any number is 1. So that's the scientific notation of 4.63. So here. So there are more examples on my slides. Can wait this here. So this is what I explained earlier when we go over the place values. So 10,000, 10 times. There are 4 times to multiply. So scientific notation of that value is the power 4. So especially you can use this information to convert a scientific number back to standard form. Like when it is written in 2.65 and 10 to the power 2. 10 to the power 2 is 100. So you are going to multiply 2.65 by 100. So it's 165. Even with the decimal signs, you can use these values to multiply. And why it is important? Sometimes in science, we have some large numbers or small numbers that we can't use the standard form to write it like this. So it requires a lot of space. Right? So we can simply convert that number into the scientific notation. So that's one of the advantage. And also, we are going to talk about the significant figures and rounding of rules. Sometimes when we round up a number into certain number of significant figures, we may need to express that answer only in scientific notation to give the required number of significant figures. So I will talk about that in chapter 1. So these are some examples of scientific notation. And again, it is very important to learn how to enter scientific numbers into a calculator. So practice this with your calculator. And there are different buttons. So some calculators may have EE or EXP. So one of the thing that I'm going to use always is 10 to the power x. So this is another option in most calculators. And there are some other options as well. So practice how to type each number with your calculator. Okay, so these are the steps to convert a number into scientific notation. So first, move the decimal point to obtain a coefficient that is at 1 but less than 10. So it should start from at least 1 or less than 10. So we're going to shift the decimal place until we reach to 6.4. So now our coefficient is 6.4. And then express the number of places moved as a power of 10. So from here to here, we need to shift it 4 times. 1, 2, 3, 4 times. So we're going to express it as a power. So then we are going to combine the two. 6.4 times 10 to the power 4. So this gets positive if the number is greater than 10. And if the number is less than 1, it gets negative. So we are going from here to here. So it's 2.1. So now it's in the range. So we shifted it 2 times, but it should be negative because this number is less than 1. Now we are going to combine 2. It's negative. Don't forget this because some calculators might give you the answer in scientific notation, and my answer may be in standard form or the other way. Okay. So if you're not going to see your exact calculator display on my answer, this might be a reason. So there might be other reasons, but this might be another reason. Some calculators may show answers in scientific notation. So there are 3 practice problems on this slide. So find the answer. Okay, I want to highlight one thing here. Yeah, I'll explain that when we discuss this big question. So try to find the answers. Try to use the scientific notation that I explained. So your coefficient should be in the range of 1 to 10. What is the answer to A? So this is a number less than 1, so you should end up with a negative exponent. The first one is product, guys. So now we are going to shift the decimal place 1, 2, 3, 4, 5, 6 times. So coefficient is 8. Answer 3 is also correct, but this coefficient, I mean, Answer three is the same value, but it's not within the range that I explained. So it should be within 1 to 10. So this one, answer should have a positive exponent. So this is not possible. 1, 2, 3, 4, 5, 6, 7 times. So its exponent should be 7, 7.2. The next one, what is the answer? What is the answer on C? 1, 2, 3, 4, 5 times, 5.4 times 5. Its answer is 3. Yeah. I have another slide that 2.75 times 10 to the power negative 5. So what is the standard form of this number? Yes, it is. So we are going to shift decimal place to the left side to remove the negative exponent. So we can remove one times like that. So we need 4 more times. So we are going to add 4 more zeros equal to now the decimal place is here. So 4 zeros to 75. Next one, 1.3 times 10 to the power 4. So it's going for the large fraction. So it should be greater than 10. So this is not a choice. 3 is only 1 digit, so we need 3 additional zeros. It's going to be 13,000. The last one is -1. So we are going for the lower side, so we are going to shift to the left side 1 more time, so it's 0.91. Any question? Okay, so I think that's my last slide from chapter. Basic mathematics. Okay, so that's all for today. And I'm going to start chapter 1 on Friday. So again, we are meeting on Friday at 10 in this classroom.